This is exercise 15.6, question number 3. Find correct to one decimal place the lettered angles in these diagrams. In part A, we need to find out angle A. Since we know that the side opposite to the angle is known as the opposite side, and the side that is adjacent to this given angle is known as the adjacent side, denoted by A. So we are going to apply from so ka to the trigonometric ratio that involves the opposite side and the adjacent side. As it is evident from the formula, I should be using tangent of the angle A, that is equal to opposite side divided by the adjacent side. The values are 7 centimeters divided by 10 centimeters. So this gives A equals to tangent inverse of 7 by 10. And when we use our calculator, we need to use shift 10 7 divided by 10. That is shift plus 10 plus 7 divided by 10. So this will give us an answer. A equals to 34.9920. Since we need to have the answer of the angle to one decimal place, that is why it is going to be recorded as 35.0 degrees. Okay, now it's part B. Again, it is the same pair of the sides, the opposite side and the adjacent side. So again, we would be using tangent in this. So angle B is going to be tangent inverse of 9 divided by 2. That is 4.5. Which gives an angle of 77.471. So the angle up to one decimal place, sorry, is going to be 77.5 degrees. Okay, now for part C. If I start from C, the side opposite to C is 4 and the side adjacent to C is 5. So again, angle C can be calculated as tangent inverse of the opposite side divided by the adjacent side. So this will give us, using our calculator on the same pattern, tangent inverse 4 divided by 5, that is 38.659. So the angle to one decimal place is going to be 38.7. This is 659 rather. So that's why this is going to be 38.7 degrees. Okay, now for angle D, this 5 becomes the opposite side and this 4 becomes the adjacent side. So this is going to be tangent inverse of 5 divided by 4. which is 51.34. And writing down it to one decimal place, we get the angle D to be 51.3 degrees. Okay, now this is part D. We observe that again, this is the opposite side and this is the adjacent side. Again, we are going to have the use of tangent ratio, and for part F even, this is going to be the same case. Okay, let me do its part E then. That is going to be angle F is equal to tangent inverse of 1 divided by square root 3. Using calculator, we get 30 degrees. And now since we need to give the answer to one decimal place, it should be written as 30.0 degrees. So that is question number 3. Okay, now I proceed to question number 4. A ladder stands on a horizontal ground and leans against a vertical wall. The bottom of the ladder is 2.8 meters from the base of the wall, and the ladder reaches 8.5 meters up the wall. Calculate the angle the ladder makes with the ground. This is the ground and this is the angle we need to find out. So again, this is the use of the tangent ratio because the side opposite to the angle is known, the opposite side, and the side adjacent to this angle, that is the adjacent side. So that's why angle, let me call it as theta, is actually equal to tangent inverse of the opposite side divided by the adjacent side, or if I replace the values, 8.5 meters divided by 2.8 meters. So when I use the calculator to calculate it, I get tangent inverse 8.5 divided by 2.8, which gives 71.76 degrees. And since we know that angle has to be retained to one decimal place, so that should be 71.8 degrees. So that is the answer to question number 4. Now it's question number 5. The top of a vertical cliff is 68 meters above sea level. Okay, then a ship is 175 meters from the bottom of the cliff, and then calculate the angle of elevation of the top of the cliff from the ship. The angle of elevation is the angle that is made above the horizontal level. So in this case, again, if I call this as angle theta, the opposite side is given, the opposite side to the angle, and the adjacent side to the angle is given. So we would be using tangent ratio. So angle should be equal to tangent inverse of the opposite side, that is 68, and divide by the adjacent side, that is 175. So using the calculator, shift tan 68 divided by 175, which gives 21.23, and giving the answer to one decimal place, it should be 21.2 degrees. That is the answer to question number 5. Now it is question number 6. O is the center of the circle with OM equals to 12 centimeters. In this one, calculate AM. We need to find out this. Now again, the angle of consideration is 42. The opposite side is given and we need to find out the adjacent side. So we would be using tangent ratio with respect to the angle 42. That should be equal to the opposite side, that is 12, divided by the adjacent side, that is represented by AM. So we need to cross multiply AM times tangent 42 equals to 12. So the side AM is going to be 12 divided by tangent 42 degrees. So using our calculator, we should be just using 12 divided by tangent of 42 degrees, which gives us 13.32. 13.327. So which should be written as 13.33. Let it be like this. Centimeters. Okay, now for part B, calculate AB from A till B. So AB is obviously 2 times the side AM, that is 2 times 13.33, which gives us 26.65. I've just used the whole answer that I got in previous part A, and I've just multiplied it with 2. So the answer from the calculator is 26.65470036. So retaining our answer to only one decimal place or 3 significant figures, that will be 26.7 if we give the answer to 3 significant figures. Okay, that was question number 6, part B. Okay, now it's question number 7. The right angle triangle ABC has hypotenuse AC equals to 7 centimeters. Okay, let me draw a right angle triangle like this, and then this. So if I label it to be AC, hypotenuse is 7 AC, and then the side BC, that means the right angle is at vertex B. So this side is 3 centimeters, and we need to calculate AB and angle ACB, this one. Let's call this as angle theta. Okay, in first part we need to calculate the length of the side AB. For that we can use Pythagoras theorem. Hypotenuse square equals to base square plus perpendicular square. So this is going to be 7 square equals to 3 square plus AB square. So this is 49 minus 9, because when I shift this 3 to this side, the square of 3 is going to be 9. So AB squared is going to be 40. And when I need to calculate its square root, that is going to be square root of 40, which will give us 6.3245. Square root of 40, and that is obviously equal to 6.32, giving the answer to only three significant figures. Okay. Once we have calculated this, now we need to calculate the angle ACB. For that, I need to see that since I've got the side AB now, but it's better and recommended to use the sides that were given in the question originally. So uh, the adjacent side to this angle is known, and the side opposite to the right angle, that is the hypotenuse, that is known. So I would be using a trigonometric ratio that involves adjacent side and hypotenuse. So ka to this is the trigonometric ratio, that is cosine, that is to be used because it involves adjacent side and the hypotenuse. So cosine of the angle theta, that is equal to adjacent side, that is 3 centimeter, divided by the hypotenuse, that is 7 centimeters. So angle theta is going to be cos inverse of 3 by 7, which from the calculator is going to be calculated as by pressing first shift, then cosine, then the fraction key, or directly 3 divided by 7. This will give us 64.623. 64.623. And if I give the answer to one decimal place, it is going to be 64.6 degrees to one decimal place of the angle. So that was question number 5 and exercise 15.6. I hope you would have understood it.